everyone to the 26th Annual Kuehnast Lecture. Oh, the mic won't work. The mic is just streaming. Is that better in the back? So I'm not, okay, thank you for the heads up. Welcome to the 26th Annual Kuehnast Lecture, named after our former state climatologist, Earl Kuehnast. I want to thank the Kuehnast family who made this endowment to allow this lecture series to happen. Also provides awards for students to travel to some conferences and other support for them. So thank you to the family. Thank you to many of you and others who have contributed to the fund that also allows us to put this on. I want to thank the Kuehnast Committee for helping to plan this. I want to thank, special thanks to Stacy Nordstrom, who worked on communications for this lecture series, and to Carrie Jarko for handling all of the logistics for this. So thank you and welcome. What we would like to do as a kickoff to this lecture series before the keynote is every once in a while a very special award is presented to someone from the National Weather Service. And so at this time I would like to invite Dan Luna and Michelle Margraf up to the front. Corey Loveland is also here from the National Weather Service here in Chanhassen, and I'll hand it over to them for this special award.
Thank you, Tracy. The reason we have to have Michelle up here along with Corey is we got so much hardware to hand out to Mr. Reckers, because he's been a very valued observer for decades, not years, decades. So I'm going to say a few words and I'm going to ask Michelle to talk a little bit more in detail. In the National Weather Service across the country, we have about 12,000 co-op observers, as we call them, all volunteers, 12,000. Steve has been doing this for over 50 years, and he told me at lunch today he's got another 50 in him, so that's a good deal for us. Seriously, there's probably only about 10 people today out of 12,000 that we can say that about, 50 years. I've been doing a few things for 50 years or longer in my life, but nothing that really matters, Steve. So the data these folks provide the National Weather Service is critical in so many areas. It's been used in engineering studies. It's used for river flood forecasts in the springtime. It's used for temperature verification. Used for studying what's going on with our climate. It's science. It's not opinions that are driving our decisions in the agency. It's data that real-time people provide us, as well as our satellites and other observing systems. They all complement each other. So very, very important. So Steve, would you please come down so we could personally congratulate you? And Michelle, I'll have you say a few words.
I just wanted to point out, like a lot of us in this room, we can relate to this. It's been a lifelong passion for Steve, recording the weather. We were just talking about at lunch today how you started taking precipitation measurements when you were young. You put was it a coffee can outside, and he would take the measurements of rain and snow using a yardstick, I think you mentioned. Your family, your father gave you a temperature sensor when you were in 6th grade. And he was actually marking down these measurements twice a day when he was a kid, with temperatures and some rainfall as well. So it's been a lifelong passion for you. I actually wrote down some of the most extreme weather that you've recorded over the last 50 years. I calculated it too. There's actually, over 50 years, you've taken 18,250 observations. Just amazing. It's amazing. You noted that the Halloween blizzard was one of your most memorable storms. A lot of us here remember the Halloween blizzard of 1991. Yes. In your backyard, you measured 22.9 inches of snow from that blizzard. So, for the rain category, in 1987, we had a huge flood in the Twin Cities, and you recorded 7.43 inches, with a lot of flooding impacts from that event. So that was a memorable one. And talking about heat, because we get everything here in Minnesota, except hurricanes, but in 1998, we had that really hot summer. You had 5 days that were above 100 degrees at your station. And then the opposite side, you got down to 33 below. That was in 1996. When the state record was set in Tower at 60 below, you hit 33 below in your backyard. One thing I do want to mention, right here on this picture, you see the shelter here where Steve takes the temperature observations. That is the original shelter back 50 years ago, and he has kept meticulous care of this station. They usually last about 30 years, and we have to replace them. This looks brand new in this picture here. He's painted it, he's sanded it, he's taken loving care of it, and he also has the original thermometers as well, which is incredible. So it's just amazing. And we said, you know, we have this new technology now. It's a wired temperature sensor. You can read it from inside your house, get the highs and lows. You don't have to go out when it's 33 below in your backyard. Steve said, you know, I want to kind of keep the old instruments going, that consistency, keep trying to measure with the old equipment. So he has kept this equipment, the older equipment, to keep the record going. But on top of that, he said, I'll take measurements with the new equipment too, so you can compare them. So he's doing both of those. He's doing the new maximum temperature sensor, which is the inside readout, plus the old sensor. So just imagine Steve out there in the winter spinning the thermometers to reset them in the shelter every observation. So that's just a few things to even mention about 50 years, but I just wanted to say on behalf of the National Weather Service how grateful we are to you for taking measurements. And today, just to express how rare it is to have an observer for 50 years, the National Weather Service actually presents an award to families, so in families, if they've taken 50 years of records, because it's usually a generational thing. A family will start, and maybe the son or daughter will take over the station. Steve has actually done the observations himself with his family, helping out. Your daughter, you're mentioning, helped, and I'm sure other family members were there to help as well. But we have an award just for Steve for 50 years, and then we also, on top of that, have a Family Heritage Award to present for 50 years of the Records family. So if Sue would like to come up and join us, Steve's wife, Sue, is here as well as part of the Records family. And you have the Records Family Award there. That's for 50 years of the Records family taking measurements. And then here's the award as well for 50 years for Steve being an individual observer for the National Weather Service. So thank you so much. And Tim, if we take a quick picture of that.
Oh, sure, absolutely.
Your faces are in the projection, though. A little bit.
Oh, it's a side. Step forward.
You just step forward a little bit. That would have been great for Halloween.
Thank you. At this time, I'd like to invite Dr. Cole Rosen to come forward. He is Department Head of Soil, Water, and Climate to say a few words. Thank you.
Great. Thank you, Tracy. For those of you who don't know, this is Tracy Twine. She has taken over for Mark Seeley.
I guess I forgot to
You forgot to, yes, and I'm going to have a few comments on that in just a little bit, but thank you, Tracy. Yeah, it's a pleasure to be here, and welcome to the 26th Annual Kuehnast Lecture. I would like to also echo Tracy's comments. Thanks to the family for the endowment. We could not do this without them. I'd also like to thank our featured speaker, Marjorie McGuirk, I got that right, for coming here to speak to us on a very timely topic, how climate and weather, I guess, affects our daily lives, whether it's the hurricanes down south or our excess moisture and how it impacts our farm fields. It's a very important topic that needs to be heeded by all, especially our policymakers, and look forward to your lecture this afternoon. So, as you know, this is the first year without Mark Seeley in the department. Life without Mark is definitely different, but I am happy to report that we have been given approval to search for his replacement. Now, of course, nobody can replace Mark, but we're going to try. And we do have a search committee working on it. We've had over 70 applicants for this one position, so it's quite a lot of interest in this particular position. We're looking for somebody who has a passion for communicating climate science to agricultural producers and other stakeholders. It's a 60% extension position, 40% research position. And funding is coming from a special legislative initiative to kind of increase capacity in the college for agricultural production and natural resources. So the search committee now is narrowing down the pool of applicants we have to get it down to 3, so they have quite a job ahead of them. But we're going to have interviews, hopefully, within the next few months. And it is my hope that this position will be filled at this time next year. So stay tuned for that. It's really exciting. Some other very quick departmental news. We've recently hired an irrigation specialist. And this is a position that's going to be very integral to the department, particularly with the climate group, because all of these measurements that we make on a daily basis for a climate impact on how we irrigate. So it's very important. So our irrigation specialist is Dr. Vasudha Sharma. She received her PhD from Nebraska and will be working in extension and applied research programs related to irrigation. And I need to thank the Department of Agriculture for helping to fund that position. So I think with that, Tracy, that's our updates. Again, I'd like to thank Tracy for stepping up and organizing this lecture along with the committee. And again, I'd like to thank the Kuehnast family for their support, and looking forward to the lecture from Marjorie. So thank you very much.
Thank you. Okay. All right. Well, yes. We're very honored to have Ms. Marjorie McGuirk as our keynote speaker today for our annual Kuehnast Lecture. Marjorie McGuirk's abstract states that she became a climatologist before climate was hot. And many of us were talking about this the other day, and we love that statement. It's great, and it also made me think of what a powerful statement it is. We're at a time really where, I don't know, maybe half of the people in the climate science community now were around before climate was hot, and the other half have only known climate to be hot, or to be sort of this hot button topic. We were always told, stick to non-controversial topics when you're making small talk at a party. Weather is a good example. You can always talk about the weather, and it's not controversial. And climate used to just be average weather. So what's the problem? So here's an example of weather. You'd say, hey, how about that snowfall that they got up in Bemidji? Yeah, and an example of climate would be, well, yeah, I heard that's the most snow they've got in 25 years. So that's pretty safe, pretty benign, no problem with that. The climatologists were doing their important science at the time. They were keeping all sectors of the economy going, and really the most controversial public engagement is convincing people not to read the Farmer's Almanac. Now we're making progress with our weather technology. We're able to give people more warning and more specific information about where tornadoes are, where hurricanes are, and lots of preparation for natural disasters. We know so much more about Earth's climate, how humans are changing it, and how Earth's climate interacts with other Earth systems, including society. Societal sectors like public health and like transportation. However, we still need to tell people to not read the Farmer's Almanac. Climate's hot now because the public is learning more and more about how climate impacts our lives. So I'm so thrilled that Marjorie McGuirk is here today to talk with us about climate and society. Ms. McGuirk is a professional meteorologist and a climate services specialist. She received a BS in atmospheric science from Old Dominion University. She did graduate studies in aerosol science and air pollution at the University of Washington, and holds a Master's of Liberal Arts in Climate Change and Society from the University of North Carolina, Asheville. For nearly 4 decades, she has applied climate science to solutions in many sectors such as energy, transportation, and public health. And she likes to say that she makes sense out of climate science as it applies to policy, planning, and infrastructure. Following a long career with NOAA, Marjorie consults with Case Consultants International, where she is founder and president. As an expert consultant for the World Meteorological Organization's global framework for climate services, her works underpin international technical collaboration in climate and health, disaster risk reduction, water resources, and agriculture and food security. As a lead U.S. government reviewer for the 5th assessment report by the Intergovernmental Panel on Climate Change, she concentrates particularly on impacts, adaptation, and vulnerability. Before retiring from federal service with NOAA's National Climatic Data Center, Marjorie served as the special advisor to the director, as chief of staff, and as the National Partnership Liaison with Regional Climate Centers and the American Association of State Climatologists. So, with all that, I would love to welcome Ms. Marjorie McGuirk down there. So this won't amplify your voice, but will be strained.
Okay. Does anything amplify my voice?
It doesn't, so
Oh,
gotta.
okay. I just learned I have to belt it out, that there's not a microphone here. I am thrilled and honored to be here to share with you my story on climate and society. Talk a bit about the past, the present, and the future, all through the lens of transportation. It could be a different sector, but it's a moving story. And I like to start with me. I was born at a very young age. My family was all born at naval bases on the east and on the west coast. This car behind me is near the Norfolk Naval Base. Today, seawater would lap the hubcaps of this car. The church where my grandmother went, not too far from there, now has a sign that posts high tide and low tide. Services must be at low tide. The parking lot wouldn't welcome a car at high tide. You would have to wade through salt water on your way into the church. It would be years later that my mother would be someplace other than Tidewater. When she visited me in Colorado, landing at Denver International Airport and making the drive north to Boulder, where then I worked for NOAA's research laboratories. On her way there, looking out the window, she asked, "Who cut down all the trees?" I said, "Mom, this is the Great Plains. There are no trees." "No, that can't be. The climate you grow up in is the climate in your body and your soul." She'd never imagined there could be a place without trees. I'm going, waves of golden grain, you know, it's in the song. It was very difficult for her to understand that. Meanwhile, back in this place, this time, where I was born, was the year that the federal highway system was born as well. And the year back in the USSR where they send up a satellite called Sputnik. The Soviets were circling the Earth and looking down on us, and the United States decided to send a person to the moon and bring him back safely again. We did those things and other things not because they were easy, but because they were hard. And the whole society was geared around movements, sending objects through space, through icy water under the Arctic, probes through the atmosphere of Venus, eventually to the moon and to Mars and beyond. My dad became a Viking, the 700 or so men and women who landed us on the other planet. Mechanical engineers became aeronautical engineers, and aeronautical engineers became aerospace engineers. And the entire generation was geared towards how do we move, how do we gain science, and how do we explore further. Then a marvelous thing happened to me. All my siblings, Kathleen, Rosemary, Jane, Barbara, Loretta, Bill, and Mary, all got motion sickness. So I got all the free family flights out of Pat Henry Airport and got my pilot's license before I even knew how to drive a car. On my way to getting my pilot's license, you have to take an exam, a third of which is meteorology. So I decided to become a meteorologist then and there, hoping to be an aviation meteorologist specializing at the flight service station, where I sometimes volunteered, coloring in the warm fronts in red and the cold fronts in blue. To pay for this, I got a job at a marine institute. I entered an ad that said, must be able to drive small boats. It didn't actually say, has ever driven a small boat. But I thought, how hard could it be? It's not rocket science. It's not going to the moon. An airplane has 3 axes of motion. It has the axis of roll, the axis of pitch, and the axis of yaw. I figured a boat at most had yaw, so I got the job. It wasn't too much longer that they realized, in fact, I didn't know how to drive a boat, and actually they promoted me, and I became a technician on a research vessel working out at sea. There were airplanes flying over while we were testing things in the water. At that time, we called it aerial photography. Today it's called remote sensing. Working on a research vessel means you work on shifts 4 hours on, 4 hours off, which is awful. If you've never done it, I will tell you, shifts on ships, shits. Losing my dream to become a meteorologist for the National Weather Service because that involved shift work, I luckily landed a job in climatology, which is a 9-to-5 job. It's great. It can wait till Monday. You might be able to pick me out of the crowd. One of my very first jobs, customer calls, was from a group called Flying Tiger Airlines, a group of ex-pilots from the war, and they wanted to know about climatology of airports across the United States by time of day. Their idea was to have a package delivery system. So they wanted to know the visual flight rules, the best minimums for 5 to 6 o'clock in the morning, 5 to 6 o'clock in the afternoon. Not the number of days with fog, rain, or hail, but what's the best ceiling visibility wind speed in the morning and the afternoon. A different way of doing climatology by hour of the day. That was a fun job. That Flying Tiger Airlines is today was bought out and known as Federal Express. I went from that job to, very proud to say, the cooperative data branch of NOAA's National Climatic Data Center, so I undoubtedly received some of your earlier handwritten observations, so thank you very much. It was always a thrill to get the monthly package in and start doing the data quality control. So the next decades flew by. Color photography was invented. I worked for the National Weather Service, decoding working with a team that created the Automated Surface Observing System. You know, so much of our meteorology was geared towards aviation. Isn't it strange that we went from this symbolic language for weather? One of the first internationally exchanged sciences ever was weather, between nations in code. We did that early, and now today we have emojis. We've gone back to hieroglyphics all over again. I worked for the Climate Reference Network there in Colorado, and somewhere along the line I ended up at the World Meteorological Organization working with climate services, how to put one foot squarely in the arena of science and the other foot squarely in the arena how you use science to make decisions. Climate services span that space between those who make science and those who use science to make decisions. And that has become the theme of my work for 4 decades now. Those dialogues, and they are dialogues, climate scientists are great because they get to speak the language of all the other sectors. We have to mainstream the climate science into the processes of improved decision, always knowing that the decision is going to be made whether there's any data for the decision or not. They've got to make decisions. There might be, well, you have to keep in mind that there are many layers of decision making. And while we're focused on a kind of analysis, they're focused on decisions. The scale of decisions and the scale of analysis and time and space can go from a local to a global scale and our daily temporal scale to over centuries. Scientists work hard to reduce uncertainty, whereas people work to manage uncertainty. We like to do research because we're intrinsically driven by creativity, by curiosity, whereas the people we serve are driven by a need to do, to make, and to decide. And it's a struggle that we must concentrate on, that we must understand that decisions are going to be made with or without science. The best we can do is mainstream our science into their decisions. So that's the first third. Now I'm going to talk about how, in the case of transportation, give you some examples of climate and society working together. I like to say that the weather affects the operation of transportation infrastructure. You know, do the school buses have to be delayed today? Do you have to plow off the runway before the aircraft start? Where the climate affects the design of the infrastructure that we use for transportation. Let's use an example. We're up here in the northern tier states, so we like to make fun of Atlanta. I understand that. On the left is Atlanta, and on the right is Chicago. Both are under a winter storm warning. The threshold for a winter storm warning in Atlanta is 1 inch. In Chicago, I think it's 6 inches. That's the threshold for a warning, because it's not the amount of snow, but it's based on the capability of the population to react to the snow. So a warning level of 1 inch in Atlanta is about the same kind of societal reaction as 6 inches in Chicago. What can they bear? What can society bear? The mayor of Atlanta, after this particular snowstorm, recognized they'd made a lot of mistakes. They let the schools out at the same time industry was out, clobber the highway. Some people died. Chicago, a terrible snowstorm. Groundhog Day, was that the same storm somebody here was talking about? No, that was Halloween. No deaths, roadways clear, continuities of operation plans went into effect, people were safe. But when we talk about climate and climate change, what are the continuities of operation plans for the future? when Atlanta will get so few snowstorms, but will still get clobbered every now and then, where they will lose the capability to operate the snowplow because no one's used one. First they'll have to find them, and they'll say, does anyone have the key? How's this thing start? Much less losing the ability to operate a snowplow. So will a city like Atlanta in the future have to have a continuity of operations where they say every 5 years or so when we get a snowstorm, we'll just close the city down, wait for it to melt, take 2 or 3 days off, do school by electronic means with emojis. Climate analysis, weather affects transport. It's fun if you want to go into this section of meteorology for the students out there. There have been very good studies on what kind of parameters affect transport, particularly on the highways, freezing rain, heavy snow. You have to analyze these things, though, for the operational thresholds. Just like in aviation, 3 miles visibility, 1,000 miles ceiling. In trains, visibility under a quarter of a mile is significant, but not so much for other means of transport. In ships, freezing rain makes a lot of difference. It clogs up the wires. It's worse than the zebra mussels on the Great Lakes. It fouls the lines, freezing rain. So the threshold for action matters. We were commissioned to do a study for the federal highways. We picked several states, several sections of highways, I think about a dozen states, and our job was to figure out what kind of weather messed up freight the most. Why do we study weather on highways? If you count up all the deaths in the United States previous to Hurricane Maria, which killed people, as you know, in Puerto Rico, if you counted up all the deaths by weather in the United States, on average it's about 500 deaths a year, unless you count the accidents on the roadways. We kill 10 times that much. About 5,000 people a year die in wrecks that are related to bad weather. So studying weather on highways is an important area for now and for the future when we go to automatic cars. Our study could point out just how much different kinds of weather slow down and cause accidents for different kinds of freight. I don't know if you've ever been to a Department of Transportation traffic center. It's sort of like an air traffic control center, only it's on the ground, and you have these nice screens, and you see sections of highways and know which parts of the weather might impact your daily operations. There are roadway weather information systems. They were all collected into something called the META system, which collects almost all observations, including the observations from co-op networks that are automated. And with advanced models, you can model sections of highways and know what kind of mixture you have to do to clear the roads. It's not always a great amount of weather that impacts freight, but it could be clear skies and no weather at all. It's harder for people on the East Coast to imagine this, but blowing snow is one of the things that affects the transport most in the Central Plains of the United States. Clear skies, snow's on the ground. How do you forecast blowing snow? I think a lot more could be done in this area for people who want to specialize in it in their careers. And it's pretty cool. You could just download these cams from anywhere in the national park. Low frequency, high impact storms, like dust, are happening more and more as we get wildfires. How people respond to it, how many accidents you happen to have, depends somewhat on the familiarity of that society and that location to the potential implications of the threat. So a dust storm in eastern Washington is on your right, one in Oklahoma is on your left. One study we did looked at all of these things for different sections of highways across the United States. The blue line on your screen is the average speed of traffic by hour of the day. You can see the two little dip lines are the morning hour rush hour and the afternoon hour rush hour. The yellow line is weekends. So time of day, whether it's a work day or non-work day, matters. And to a climatologist, if you're trying to help them understand what the threat of weather is on traffic, you have to understand what their databases are like. So our analysis, we had truck information from across the United States. We only used the weekdays, and we were trying to find out, did it rain more in the afternoon rush hour or the morning rush hour? And I used data from the 2 equinoxes in March and September all across the US, so then I wouldn't have to figure out what time the sun rose in every city, just knowing the whole Earth has 12 hours of daylight and 12 hours of dark. So that made the analysis pretty easy. And yeah, and the 4 cities on that particular analysis, we knew it rained more in the evening rush hour than the morning rush hour, which told the freight operators to, if you're gonna take a break, it's the afternoon rush hour and it starts to rain, pull over. Take your break then, because you're going to be so delayed. You can save fuel, save time, save everything else by just pulling over in the rain. Fast. I thought it was fun, but I like trucks. There's another example of weather impacting transportation and the societal means to react. On the left, this is Denver flooding. A terrible storm. In multiple places, the interstate was blocked, no way to get around. Whereas on the right, this was in Arizona. Arizona highways are purposely built lower. They are built on top of ancient ditch lines. They act as the drainage channel to move the water away. They are so ready and accustomed to having roads flooded that they get an alert. Like you get an alert to say, don't park on the streets if it's more than 2 inches of snow because the snowplow is coming. They get, the roads will be a drainage basin tomorrow, don't go on them. And they use the secondary roads instead. So one flood caused catastrophic disruption to commerce in the state of Colorado. The other flood, not so much, in Arizona. We were then commissioned by the National Academy of Sciences to do a study on climate change impacts on all modes of transportation, including rail, airports, pipelines, ports and piers, and highways. I might have mentioned that somewhere along the way, I applied for a job driving a train. Again, it didn't say, have you ever driven a train? And I thought, you know, it's not like a boat that goes right and left, axis of yaw. All it's got is forward and backwards, so how hard can it be? So I had a trial one day driving a freight train, building cars in a stockyard. And if you've ever messed with trains before, like even the little ones, they hook on, what are they called? Couple, and they go cha-chink, cha-chink, like that. So you drive a train forward, you go backward, you pick up another car, you feel cha-chink. Go forward, change tracks, go back, maybe put 4 cars on, cha-chink, 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 cha. And I didn't hear the chink because I didn't hit it just right. So I didn't couple the car, and the car rolled downhill to South Carolina. That was the end of that job. I just bring that up because it's only because I drove boats badly, drove trains badly, once drove a dump truck and knew how to fly planes that I got the job from the National Academy of Sciences to do this study in climate change impacts on transportation. So never turn down a job. You never know what kind of climate science that might lead to. So the conclusion of our report on climate change impacts on transportation infrastructure was more hot weather, more hot temperatures. What would it mean? It would mean railways buckle. It would mean asphalt asphalt has melted from high temperatures. Fewer below freezing days. It would mean the load limits on northern roads, like places in Minnesota, wouldn't be able to carry as hard of a load, as heavy of a load on roads. The springtime load limits would apply sooner. More storminess would mean more roadway washouts, more riverine flooding, and sea level rise would impact decisions even now on how high you build a bridge. Can the tip top of the ship get under the bridge when there's still enough water below the keel for the ship to make it safely to port? And it would affect transportation evacuation routes and more intense tropical cyclones. That was our conclusion in 2008. Sorry if I bored you. Okay. Come back tomorrow. Increased disastrous severe weather. On the left is Haboob. It's from the Qatar Meteorological Service. Haboobs have already been predicted and observed in eastern Washington state. When I was an undergrad, that wasn't even a word. The lower left, I'm told derechos have happened. Michael Pilecki was the first climatologist I met who studied derechos. This derecho happens after an extended period of excessively hot temperatures. It has a massive convection. When the storm first hit and straight line winds ran through, the East Coast, Washington, D.C. suffered about 12 deaths when trees fell on cars. 3 weeks later, when power still had not been restored, another 36 people died of heat stroke. The capacity of a society to respond is built in to where they grew up, where they were born, and where their society is able to be resilient. Here's 4 examples in the upper left. Not too far from here, Pattonsburg, Missouri. After several floods of the Mississippi River, you can tell where the Mississippi River basin, this doesn't show up. You can tell where the tree line path was, where the Mississippi River was. It jumped, it moved. You have the Mississippi River Dam between Minneapolis and Missouri. This is below the dam. The town decided to relocate rather than suffer another flood. In the upper right is Greensburg, Kansas. Tremendous tornado, took out everything above ground. But the roadway was still there. The mode of transport was still there. The buried assets were still there, water lines, power lines, internet lines. So they rebuilt in place rather than relocate. Lower right is Alaska. With global warming, what used to be a solid shoreline block of ice is now not solid, now melted, and now sea waves can clobber and tear away the coastline. The town has voted to relocate. In the lower right is Phoenix, Arizona. It's still there, of course, but it's suffered a couple of calamities lately. Excessively high temperatures, which has melted asphalt, but also has suffered in the region extensive wildfires. How long will the people of Phoenix, Arizona be resilient to the kinds of weather they grew up with and they're used to, but how long can they continue to be resilient? I told you about that first client that I had looking at the ceiling visibility wind tabs for all the airports across the United States. Here's one from Minneapolis. You could probably just look at it and tell where your winds are from, the northwest most of the time. So your runway is faced so that airplanes can land and take off into the wind. By the way, the number on a runway is numbered by magnetic north. I didn't know if you knew that, But the layout of, this is not Minneapolis down here, it's Alaska. I love the town here, it's really pretty, but Alaska is a little prettier. And when the mountain comes out, it's not very often, so I put that picture here. Next time you fly, look down at the little numbers on the runway and see which way your runway's facing. As I mentioned, I was flying out of Patrick Henry Airport. Runway 5 is where I learned to fly. Many years later, 2 decades later, I go back to the airport and it's runway 6. I'm going, what the heck? They built a new runway? And it took me a while, and then I realized from the time I learned to fly to now that magnetic north has shifted by 10 degrees. That kind of made me feel old. So it was the same runway. But you have to know that though they're named by magnetic north, they're placed depending on the prevailing winds and other things like the conditions of temperature, visibility, how dense the area is, how cold it is. When I flew in the Tidewater region, I could do 3 takeoffs and landings in about 20 minutes. On a cold day, maybe 30 minutes. On a cold day, high pressure, lots of thick air. When I moved to Colorado, 5,000 feet, it would take 20 minutes to do 1 takeoff and landing because the air's so much less dense. And when I moved to Asheville, North Carolina, August had 28 days with fog every single morning in August. I could never fly before going to work. Nowadays I could because it no longer cools off at night. It doesn't cool off at night as much, so there's no fog. So they could adjust their whole airline schedule because of global warming. You don't reach the dew point, no fog, clear skies, days with fog have gone way down. So I was thinking about this when I was commissioned by the Academy to write, the Academy like I'm a star. The Academy. I like to thank the Academy. So higher altitude airports have longer runways. I was thinking about Phoenix. With more days of higher temperatures, the number of days of limited operations will increase. And we named in our report which airports they would be. It seemed to be a lot of airports, and we got conservative and we cut the number back before we actually published. But Phoenix, Arizona was in there. And the direct quote was, global warming will curtail some operations at high altitude, high heat airports. So when this happened, I saw it on TV, and I heard this lady on one of those buses from the airport to the hotel say that her flight was canceled because of high heat. I was really, really happy. I was like, called it sad, but I was happy. You know, some things, we didn't really expect to see the things that we projected in our paper to actually happen already, but in fact it has. The latest National Climate Assessment Science Report is out. Some of the bullets that I took from that paper are on the screen. Some of them are scary. For you all, you like snow? You told me that? You like the snow events? Gonna have more of them? Not really more frequent, but when you have them, they'll be bigger because a warmer atmosphere holds more moisture. Hail is more intense. Somebody asked what intense hail means. I said, ask, who's that state climatologist that did a whole story on the record hailstone that he found in North Dakota?
Oh, Lecture?
Huh?
Lecture?
We'll think of it in a minute.
Yeah.
Expect multiple simultaneous events across the country. So the reinsurance companies are very worried about this because how do you insure across a country when bad things are happening in the same year in multiple locations? I'm gonna switch to the last part where we're kind of looking towards the future. Climate change and transportation is still the theme, but I'm looking at the Arctic. Most things that control our climate stay the same. We have the same geometry between the Earth and the sun. We're tilted on our axis. We'll still have winter in the northern hemisphere, summer in the southern hemisphere. the equator will still have 12 hours of daylight. They don't have dusk and dawn. The sun comes up, the sun goes down. It doesn't like do here, oh, the sun will rise in another 3 hours and you've got a little bit of glow in the sky. It's up, it's down. That will still happen in the tropics. You'll still have 4 seasons in the mid-latitudes. Geology doesn't change, mostly. Land heats up and cools off more quickly than water. That's why the isotherms spread over the continent of Africa. The topography will stay the same. High mountains, low mountains, plains stay the same. You'll still be cooler up top. The conditions between Colorado and the coast will be the same, and latitude will still be the same. But some changes have big impacts. The heat balance of the Earth has changed. We know about heat balance, IR, ultraviolet in, IR out, because we've measured the temperature of all the planets we've been to. We know the physics is good. It's been good since I was standing by that car back there in the now flooded streets of Norfolk, Virginia. The general location of the currents would be the same, but somewhat different. As Greenland, for example, accelerates its melt, fresh water will be here. It will weaken the Great Conveyor Belt and further slow down the Gulf Stream. Already slowed, already slower, and it counts for sloshed up sea level rise on the northeast. England, New England, Europe is looking at a cooler winter as the Gulf Stream slows down. The melt rate of the Arctic is probably the most poorly modeled part of our global equation. Some say that the Hadley cell is weakening. Some say the Ferrel cell is weakening. Definitely the temperature differential between the Arctic and the equator has slowed down, has minimized. The jet stream seems to wobble more rather than go fast, and that accounts for this kind of persistent weather pattern we have, or so we say in some papers, not completely confirmed yet. I'd like to see some new climatology books that show new zonal numbers of the wind flow between the different latitudes. But what we contend is that global warming's melting the Arctic, and because transport drives the patterns of human settlements and trade routes shape the course of history, that we will see new settlements grow in the Arctic, and we'll have new transport systems. Let's look at the Arctic for a minute. The North Pole's in the middle. The stuff on the right is eastern. We call that the eastern hemisphere. It's Russia. On the left is the top of Canada. We call it the Western Hemisphere. I have to explain that to people from Louisiana because they don't know anything. They don't even know where Canada is. I could just say that because you're from Louisiana. So the yellow lines are what you call the Northern Sea Route, and the green lines are the Northwest Passage, with the new China, one road, one belt. They've planned a transit across the Arctic from Shanghai to Murmansk. The National Snow and Ice Data Center in Boulder very well maps the movement of ice and the amount of ice. And I think I want to start this video. Does it work? And I'll advance it.
This core, a smaller fringe of seasonal ice, froze each winter and thawed each summer. Old ice eventually drifted out of the Arctic through the Franz
Can you hear?
Strait. New batches of old ice were built in the Boca
Oh.
Gyre.
Oh,
The gyre was a nursery
Doesn't work?
where young
Okay,
ice
never
grew
mind.
thicker and stronger.
Yep, that didn't work. Sorry. It worked in the test. There we go. It did work? It started?
20 to 30 years.
I don't know how much time because I could skip it. Oh, we got too many things going on. Oh, no, that's not it.
It's not
Let's skip
going.
it. Let's skip it. Let's skip it. Okay, give me back to where I was.
It's on your web, on a web browser instead of in your PowerPoint, so you'll have to switch to the web browser.
She is on the web browser, but it hasn't switched.
I'll just go back here. Very nice work by the National Snow and Ice Data Center. If you like that sort of thing, it's good. They don't work shifts, 9 to 5. Great job. It was one person's job to do 2 tweets a day. Things are changing in the Arctic so fast. That's their whole job, 2 tweets a day. I could have gone for that. So no matter how much ice you have to look at the impacts and where the decisions are made. These graphs on the top is the northern sea route. I explained that before. That's the one on the eastern. That's the one on the eastern hemisphere, and then the Northwest Passage on the bottom. That's the one on the western hemisphere. So the Arctic Council and other parties did a projection of what they thought the amount of sea ice would be in the Arctic. The yellow star is where the actual is. Okay? The gray area is what the best projections are. The yellow star is the amount of sea ice that was there. So what's important to the decision makers is how much ice is there and can I get a ship across? So this combines the old ice, new ice imagery from NOAA, and the yellow lines are ship transits. You see, here's the Hudson Bay. That's where the polar bears grow. As it turns blue, it means there's no ice. And the yellow lines see we're starting to go closer and closer to the North Pole. Here's Alaska. Here's where you can see Russia from your house. And so forth. We're having more and more transits every year. Romance just sent a container ship across with 5,000 containers. That's really a small number compared to what they send through the Suez Canal. They send ships with 14,000. I said Suez, I meant to say Panama Canal. And the Northern Sea Route and the Northwest Passage. They're opening for shipping, at least for destination shipping, maybe not transit shipping. Transport drives the patterns of human settlement. I said that in the introduction to this part, but why do I say that? Here's the map of the annual freight tonnage, where we move freight. You see your Mississippi River promenades this map. It's big. When we grow a city, it's always been grown at the intersection of trade routes, just not in the Netherlands. And I learned that through the liberal artsy people, not through the climate scientists. So you look where goods are traded, and there you'll grow a city. It even happens on subway cities. Subway cities like Washington, D.C., they grow a new subway station, somebody starts selling things there, and then you end up with something like Crystal City. That was nothing but a subway stop, and now it's a town. So to show this a little further, oh no, I need this one. Can you make this one go?
Probably need to.
How do I do? This one's on my computer though. This one, oh, there it is. This is not an internet. This is online. Oh, damn it. This is not good. Show me.
I don't necessarily use this very often. So is this like on your computer?
Yeah. It's my own thing. Okay, maybe
Did you have the whole folder copied over?
I'll do this. Yeah,
Okay. It
I'll
must
do
not
it
be-
outside of presentation
yeah, you might
mode.
Need to do it.
You could go into a web browser and shut
It's not a web browser. I'll do
It
it.
should be on your.
No, I'll do it here. Sorry, guys. 7th inning stretch. Okay. All right. So our nation started off by colonies, our new nation, I suppose. And for a time, this is not showing.
Go back to your presentation.
I'm here. It's not on the presentation mode. I hate this.
When I did it on that one, it's just really hard to see the button. Let me see if I can do it for you.
Presentation mode there. Go to that one. All right. We were here a whole hour going through all that. I'll just have to dance. I'll tell the joke. I've told them all. I'm all out. All right.
Up on there?
Yeah, make it go.
No.
There's a little thing there.
Yeah, I know. It's not showing up on that one.
Damn. All right.
Is it?
Try that.
Yeah. I don't know why it's in this mode. I don't ever use this mode.
I'll skip it. I'll just say it.
Okay. 'Cause it's
What
working on
this,
one.
what I will tell you, I hate it when speakers say what you can't see, so I won't do that. But what happened in the United States, we started off with the Nina Pinta and the Santa Maria on the East Coast. We were 13 colonies. Everybody lived on the coast. Today when I hear even NOAA people say, oh, our population on the coast is growing, well, it's not really true. Our population is growing, but it's not growing at a faster rate along the coast than it is on the interior. It's not really wise or fair to spend more on warnings and services and National Weather Service and NOAA on the coast than it is on the interior. The rate of growth is the same. In the beginning of the United States, everyone lived on the coast. We moved inland when we began to trade, first with pelts and beavers and deer and stuff, trading back to England. And those trade routes began along the riverways, along the Ohio, along the Mississippi, along the Missouri. Then we discovered gold in California, and clipper ships moved from New York around the Panama Canal on up to the coast of California to collect gold and move it back again. And then we said, we need a railway. And the railway line was drawn across the United States about 100 years later. And along that line, you needed water because it was coal trains. Forts were designed around watering holes, wells. Fort Monroe, Fort Collins were watering holes for steam trains. They were trading the water with the train, and the town grew up from there. The railway lines went in, clipper ships weren't needed anymore. Chicago grew, trading stock across the United States, and towns grew up wherever those transportation routes let people trade goods. Wherever we go, we stay. Where we can go, we do go. That sounded nasty, wasn't intended. Can I have this presentation mode back on? Please? Okay. Nope.
It's up on there. Or it was up on there.
All right, I'm having technical difficulties here. Sorry. Let me close that. I think that's what it is. I think that one didn't close. So can we just move forward from present slide? All right. That kind of ruins my
Yeah,
thing.
it's up on there, so you should, yeah. But it doesn't have your notes, is that what?
No, I think that this is unrelated to what's there.
Oh.
Can you go back down there? That's the presentation mode.
Okay, so.
We there? No?
No, not on here. I think I'm just going to close out the whole thing and open it back up. 'Cause
Okay.
I don't really know what else to do.
I'm sorry. Let's give her a hand.
Technology.
It's the IT person always has the toughest job.
Okay, so.
Yeah, that's good. I think there might have been two presentation modes up or
That
something.
might be what it is.
Okay.
And see, this one you can actually do the video on because I have the same view on mine.
Okay.
But
All right.
let's see how far you are.
I'm almost done. Yeah. Let's do that. Make it
'Cause
big.
you can actually,
Make that guy go?
yeah.
Is that going? Is it going? See what I mean? Yes. Whatever I said before. So these dots are every time land deed happened. So it's a social database, transfer of property, how the United States grew. As the population grew, that got bigger. West Virginia, I don't know what happened to it. It was blank for a while, submitted all its records all at once. Pretty amazing. And you can see the year, 1920, moving up to the Industrial Revolution. We've got the interstate highway starting in 1950. Look how big Chicago is. And look, Minneapolis and St. Paul. You got a big dot. I'm from the East Coast. I grew up there. So good, it works. So population is related to where you can get to. On an international scale, it was the ships. And think for a minute. Ship lines, airlines. Our terminology for transport came from our first transport. Ports, then we had to call it airports, right? Ships were first, so the vocabulary came from there. And the cities and towns that were on the trade routes where a ship had to refuel, just as a train had to refuel with water, ships had to refuel, and those became towns as well. So those were the major ship routes. Those were the beginning, because all countries start at the coast, because you could get there, because you could get goods delivered there, you could trade there. By volume, the United States trades about as much as China and about as much as the EU, if you think of the European Union as a single country. What's going to happen to this picture when we can trade across the melted Arctic? Think for a moment how fast things have happened. In just 6 generations, we went from a Suez Canal, pictured on the left, little ships, little canal, to the new canal on the lower right. Change happens fast when there's commerce to be made. I project there'll be new settlements in the Arctic because the ships that cross the Arctic will have to fuel, will have to load and unload. I'm not talking transit ships, but destination shipping. And it's my best guess that these 4 towns along the coast of Russia will expand first. Why? There's already some trade there, and secondly, their rivers, these are coastal towns, and their rivers feed down into inland settlements, so there's a way to move land. And if you're someone who likes hydrology, one great demand is improving the forecast of the ice break on a river. Can you get within a couple of weeks? Can you give ships enough advance notice when they should be at port because the ice would have broken? That means the goods can come up the river without flooding the town upstream. This is what these towns look like now in the Arctic. Already trade, already ships, some minor infrastructure. They're trading lumber, they're trading metal, fertilizers. We move gravel from the Hudson Bay, the deep water port in Canada, across the Arctic, to Russia, to build land, to build facilities for more destination shipping. That's my theory. Unfortunately, it hasn't exactly worked out as planned. Population in Russia has been declining since I wrote this report, not expanding, but I think it will change soon. There's new development projects planned for all of the Arctic nations. They'll have to, whenever you move goods, you want some goods to take back with you, so transport has to be a two-way street. But I predict there'll be big changes. Maybe not yet, but maybe soon. Why does all this matter? We're in a very changing climate. All sectors of society will be impacted, not just transport, which I showed you today, but every sector that the state climatologist deals with day in and day out. Health, agriculture, aviation, insurance, tourism will all be impacted. And to help us get through this, we're going to need massive changes in the United States that are on the scale that happened between the Great Depression and the run-up to World War II. We were a nation that was more rural than urban. We had to modernize agriculture. We had to be able to build and make things like never before. Aviation had to advance. We needed mechanized agriculture. We had to grow cotton to clothe our soldiers. We needed power. We needed it now. Internal combustion engines. We had to build dams. We were producing one aircraft every 4 minutes in the United States then. We produced in the United States more goods than all the other countries combined. We've got nicer music now. Gershwin, power, high density, transportation, connected us. Skyscrapers. We are now an urban nation. The sweat,
yes, the sweat of the men of all
men and
nations
women
built America.
of all generations built this America. We do these things not because they are easy, but because they are hard. And now the latest IPCC 1.5 report tells us that this next generation has to rebuild all these things, redesign them in a way that does all these functions without emitting carbon dioxide into the atmosphere. It's not rocket science. We older people have to help them understand the burden that they bear, but understand that they can do this. My mother had never been in a part of a country where they didn't have trees, yet she was part of the generation that figured out how to get us to the moon and back, and to Mars with our probes. How hard can it be? Thank you.
Thank you so much, Marjorie. I think I've been to a Kuehnast Lecture that's made me cry before.
It's a Gershwin. Sorry about the technology.
No, thank you. It was, informative and inspirational. Are there any questions for Ms. McGuirk? Michael, let me bring the microphone to you so that we can hear your question online.
I'm glad to hear you're an optimist. With the population at 7 billion and projected to go to 11 billion, how can you be an optimist?
The question is, with the population at 7 billion, projected to be 11 billion, how can I be an optimist? I'm an optimist by nature. I read a study that if you took all the rain gauges in the United States and you stuck them together, it would cover an area of a double tennis court. I read another study, if you took all the population of the world and stuck them together, it wouldn't even cover Texas. Our Earth, our dear planet Earth, has a capacity to respond if we're kinder to her. A person at a cocktail party French group I go to asked me the same question about population, but it was her understanding when she heard the term humans cause global warming, she thought it was from our body heat. And we were in this cocktail party and it was getting kind of hot. I thought, wow, how do I answer this? No, it's not from the numbers of us breathing out heat, but it's from our means of producing heat and energy and pollution. I look at what we've done before and to know what we are capable of doing next. Poverty has declined by incredible amounts. on the planet Earth. We feed more people. We have enough food for everybody. It's an issue of distribution. There are places on Earth that, by all climate projections, will become uninhabitable by humans. There are other places that will become more habitable, like Siberia. It will take a while, but we'll get there. You never know what population's going to do. Sadly, big storms wipe out populations. Not in developed countries like ours. It's, like I said, about 5,000 on roads, about 500 not on roads that die from accidents. But then you look at Puerto Rico. 2,500 people, maybe 3,500, depending on which story, wiped out in a single storm. Developing countries have a hard time. The stress on populations becomes worse as the climate becomes worse. But the stress and the motivation of people to act and decide and build and improve also increases. We can do this because we always have. That's my answer. Thank you for the question. Sorry about the technological issues. We did practice so hard. I'm sorry.
Don't apologize.
Don't apologize.
You practice, things often change before go time.
Ah, yeah, that's right.
Computers like to do that. Yes.
Could you please talk a little bit more about the climate change and agricultural production from your own opinion?
Yeah, I will address. The question is climate change and agricultural production. I was telling Lou earlier that in my experience at NOAA and the National Climatic Data Center, we have found that that is one sector on a national basis that we're not so good at. It's so much better done by regional climate centers, by state climate offices, that on the scale of the United States, I don't believe the expertise lies at a national level. Even the USDA has regional climate offices now just on agriculture. On the scale of the globe and the WMO work on climate change, food, agriculture, and food security, they very definitely put agriculture with food security because it's not just production, it's also the distribution and the consumption of food. The whole thing matters. And the infrastructure to move food from production centers to consumption centers, very similar to energy. You got to move it. In a global climate change, warming world, plants grow faster, the nutrient value per bite goes down. My husband likes to say that every apple has a certain amount of taste. And there's only a unit of taste for every apple. So when you're eating a great big apple, it's just not that good per bite. But humans keep looking for the taste, so we overeat looking for better tasting food. More scientifically, the nutritional value per unit of food declines in over rapidly growing food in some of the projections by the IPCC on climate change impacts on agriculture. So I would like to finish sort of answering your question by saying it's state climatologists and regional climate centers have become even more important as you look to agricultural production in a changing climate. Yes, ma'am.
So I really liked your talk. You made a point of talking about how United States has dealt with between Great Depression and World War II, what they did, and that kind of shows you what you're capable of.
Yes.
Climate change is a global problem.
Yes.
So in now looking like an increasingly polarized world, how should we address global issues which requires global policy making and global collective thinking, collective decision making?
Okay.
How should we address it?
Okay. The question is about political polarization, climate change being a global, not a global issue that takes global collaboration. Earlier today, we were talking about it when you move from a place like Canada to the United States, or even from a northern tier states to the south, you realize people have a different opinion of climate change. We're in a period of rapidly changing flux with our own policy on climate that's also reflective of policy and science in general. We have liberals not getting vaccines for their children. It's not just the conservatives. We have conservatives saying there's no evolution, even though you're eating food that has been modified deliberately, and you take drugs that have been modified. So there's here and now or a force against science, you might say, that causes a polarization. It's not a global epidemic that there are spots in the world, but generally speaking, you go to an international meeting and you'll hear about what we need to do and how we're going to get there. It's very positive, it's very optimistic, and plans are laid. We will get there. Maybe I sound a little Pollyannish, the sun will come out tomorrow. I'd like to tell you about one plan I'm fairly familiar with. It's not agriculture, it's not transportation, but it's energy. My old boss, Sandy McDonald, has a plan waiting in the drawer to come out on how we can produce solar and wind power across the United States and distribute to areas of consumption. Right now, our coal-fired power plants, for example, are fairly close to where they produce it, is fairly close to the town in which it's consumed. The United States is a very broad country, east-west. We have 12 hours of daylight in the equinox, but the country has 5 more hours than that from Maine to California, right? 12 plus 5, 17 hours of potential production of solar energy for the country, if only we can move it from one coast to the other. These plans are ready to roll when we have the political will to act on them, to move power from places of production to places of consumption. There have been pretty good laid out procedures for how we can get there, and I think it will happen. In my studies, and maybe many of you agree, it can happen very quickly, especially in America, because we're a country that can turn on a dime, that can make a change and decide to do it. I haven't seen it in other parts of the world as much as what they call American inventiveness. Sorry, I know you're Canadian still. But I believe in the ability of Americans to act and solve the problems that we have at hand. Yes, yes, ma'am. I need someone pointing at who's raising their hand. Yeah.
This is kind of a segue from that one. When you looked at the 1920 to 1940 changes,
yes,
a lot of that had incentives built in for both companies and people that were beneficial to them personally, as well as to the infrastructure as a whole.
Yeah.
I guess I struggle with how do we end up with incentives for individuals and for companies that would make changes that perhaps need to be made, particularly for the CO2 transition. I think you pointed out really well that commerce drives so much of the change that we see, and how do we plug into that kind of energy source for changes?
Let's use another example from atmospheric science. Let's use the Montreal Protocol put into place to limit the amount of CFCs injected into the atmosphere. Does anyone remember the ozone hole? When it was first detected by NASA probes, nobody believed it. Didn't believe it. Polar orbiting satellites saw a dearth of ozone over the poles, thought there must be a problem with the instrument, eventually believed it and realized it was CFCs destroying the high-level ozone. There was a replacement in hand in that example. The industry has developed things that could be used in place of CFCs. When that was well known, that was a huge struggle, of course. Everyone changed refrigerators. I remember as a kid, my dad coming home. Now I'm the fifth of 8 children, 7 girls, 1 boy, so we had a lot of hairspray. And he made us all go out in the driveway and spray out our hairspray, and he lit it to show us how volatile it was. And that was kind of fun. And then he took all our hairspray. He says, there'll be no more hairspray. There's an ozone problem. So that's how I heard about ozone. No more hairspray. I since worked with Susan Solomon, who led the science for the protocol, Montreal Protocol. So when industry saw a solution at hand, it helped the policymakers do what they needed to do. Were policymakers leading? Was industry leading? I can't say, but they definitely were working hand in hand. There are industry solutions at hand as well for carbon. They're more complex, and they involve every aspect of society. They involve me not using a hairdryer on my nice white hair. They involved us lowering our consumption of everything. You know, you have to know when you're using your iPod, you're burning electricity. Do we have to want? Probably not. One power generator, we used to call them windmills, spans an area of about an acre, can make about a megawatt, takes about the same amount of flat land, about an acre, roughly, to generate electric power. We can do this. We have a lot of land. We have a lot of vacant land. We have a lot of farmers who can lease land for the power turbines. There's some gain there. I don't know when it will happen, but I know it will, and I know we have about 10 years to do it. Are there younger people in here who feel that it's overwhelmingly impossible? No, no, no. Yes. If we have no more?
Great. Yeah, let's take one more question.
I think we...
Thank you. And this is going to, I guess, maybe dovetail with what you were just saying and where you were going and some of the other questions. And I just want to reflect, and maybe you can help. So I also get accused of being optimistic sometimes.
Okay.
And I took a question that I found to be quite a doozy recently, and maybe you can help.
Okay.
So the young people, so I get very encouraged when I see how, how the ingenious developments that some of the young people have brought forward, some of their earnestness, some of their energy for solving problems, and it's very easy to be optimistic. And I guess the question that I think that we need help with is, okay, young people are being told by us, or by those who have maybe more life experience than them, that there's a huge burden on them, and that they can do it because it's been done before, because greater challenges potentially have been met. And I guess they might say, no, greater challenges haven't been met. This is the biggest one so far. And they also have said, you guys keep telling us this, and then we go and we take classes, and we go to the best institutions, and we learn from the best, and they also tell us, you're going to have to solve this. So I guess the question is, how do we bridge that gap? I mean, and what's the best step between this huge challenge and all of this maybe potential energy that is kind of latent within that population?
That's a good question. It is important to recognize that every generation has a challenge, has a burden that the previous generation did not have. I mean, tell someone in the trenches of World War I that there's going to be global warming, they'll go, oh, I'm scared of that. Come on. We had, what, 50 million people killed by the Spanish flu? Oh, I'm scared of that. The burden of every generation is the biggest burden of any generation. That's the way it is. Problems get bigger or seem bigger. And the previous problems aren't a burden because they've been solved. So it's unfair to think that your burdens are the worst burdens, really, because there have been worse in the past. The way to bridge the gap, as you put it, we used to talk about the gap between research and applications as the biggest gap in atmospheric science. But if we talk about generational gaps, not sure there are, really. We like to label millennials and boomers and everything else. We like to label that. But what we have now is a population of people my age and older who live beyond their design criteria. We're still alive. You've been taking observations for 50 years. We're still around, where a previous generation, we would have been dead by now, okay? So what's our burden? Our burden is to share experience and guide how big problems can be solved. It's overwhelming when you have what's called a sticky problem, massive problem. How do you break it down in chunks? It wasn't until the moon race that we invented the Gantt chart. The Gantt chart is a way of project managing. Mr. Gantt invented it. How you step through and you find the minimal number of steps so you can get from Earth to the moon. The Gantt chart did that. The Gantt chart told us the diamond path, the minimum number of steps to solve a problem. That's what we can teach them. That's how we can work together. So fora like this one are beneficial if and when the generations communicate. We might not be able to do, but we can teach and guide and share experiences. That's how we can maintain the optimism that lets us act. Of course, we can also vote, but we can also rely on the fact that other nations are acting. The United States has risen and fallen as a world leader. It may happen again. Other nations might take the lead. The burden is there, but the burden is always there on every generation. Let's solve this sticky problem by working together. Thank you so much.
All right. Great. I did not even have to invite you to thank our speaker. I think you just thanked her, so thank you.